My dear students, hello. I welcome you all in our series of lectures on cybersecurity. In the previous lecture, we studied about application security. Today, we are going to discuss about web security. So, let us start with it. Websites are unfortunately prone to security risks, and so are any networks to which web servers are connected. Setting aside risk created by employee use or misuse of network resources, your web server and the site it hosts present your most serious sources of security risk. Web servers by design open a window between your network and the world. The care taken with server maintenance, web application updates and your website coding will define the size of that window, limit the kind of information that can pass through it and thus establish the degree of web security you will have. Web security is relative and has two components, one internal and one public. Your relative security is high if you have few network resources of financial value. Your company and site are not controversial in any way. Your network is set up with tight permissions. Your web server is patched up to date with all settings done correctly. Your applications on the web server are patched and updated, and your website code is done to high standards. Your web security is relatively lower if your company has financial assets like credit card or identity information, if your website content is controversial, your servers, applications and site code are complex or old and are maintained by an underfunded or outsourced IT department. All IT departments are budget challenged, and tight staffing often creates deferred maintenance issues that play into the hands of any who want to challenge your web security. It is well known that poorly written software creates security issues. The number of bugs that could create web security issues is directly proportional to the size and complexity of your web applications and web server. Basically, all complex programs either have bugs or at the very least weaknesses. On top of that, web servers are inherently complex programs. Websites are themselves complex and intentionally invite ever greater interaction with the public. And so, the opportunities for security holes are many and growing. Technically, the very same programming that increases the value of a website, namely interaction with visitors, also allows scripts or SQL commands to be executed on your web and database servers in response to visitor requests. Any web based form or script installed at your site may have weaknesses or outright bugs, and every such issue presents a web security risk. Contrary to common knowledge, the balance between allowing website visitors some access to your corporate resources through a website and keeping unwanted visitors out of your network is a delicate one. There is no one setting, no single switch to throw that sets the security hurdle at the proper level. There are dozens of settings, if not hundreds, in a web server alone, and then each service, application and open port on the server adds another layer of settings. Add to that the different permissions you will want to grant visitors, prospects, customers, partners and employees. The number of variables regarding web security rapidly escalates. A web security issue is faced by site visitors as well. A common website attack involves the silent and concealed installation of code that will exploit the browsers of visitors. Your site is not the end target at all in these attacks. There are at this time many thousands of websites out there that have been compromised. The owners have no idea that anything has been added to their sites and that their visitors are at risk. In the meantime, visitors are being subject to attack and successful attacks are installing nasty code onto the visitors' computers. Next is known and unknown web security vulnerabilities. As you know, there are a lot of people out there who call themselves hackers. You can also easily guess that they are not all equally skilled. As a matter of fact, the vast majority of them are simply copycats. They read about a known technique that was devised by someone else and they use it to break into a site that is interesting to them, often just to see if they can do it. Naturally, once they have done that, they will take advantage of the site weakness to do malicious harm, plant something or steal something. A very small number of hackers are actually capable of discovering a new way to overcome web security obstacles. Given the work being done by tens of thousands of programmers worldwide to improve security, it is not easy to discover a brand new method of attack. Hundreds, sometimes thousands of man hours might be put into developing a new exploit. This is sometimes done by individuals, but just as often is done by teams supported by organized crime. In either case, they want to maximize their return on this investment in time and energy, and so they will very quietly focus on relatively few very valuable corporate or governmental assets. Until their new technique is actually discovered, it is considered unknown. Your site is 1000 times more likely to be attacked with a known exploit than an unknown one. And the reason behind this is simple. There are so many known exploits and the complexity of web servers and websites is so great that the chances are good that one of the known vulnerabilities will be present and allow an attacker access to your site. The number of sites worldwide is so great and the number of new as of yet undocumented and thus unknown exploits so small that your chances of being attacked with one is nearly zero, unless you have network assets of truly great value. Next is web security defense strategy. There are two roads to accomplish excellent security. On one, you would assign all of the resources needed to maintain constant alert to new security issues. You would ensure that all patches and updates are done at once. Have all of your existing applications reviewed for correct security. Ensure that only security knowledgeable programmers do work on your site and have their work checked carefully by your security professionals. You would also maintain a tight firewall, antivirus protection and run IPS or IDS. Your other option is use a web scanning solution to test your existing equipment, applications and website code to see if a known vulnerability actually exists. While firewalls, antivirus and IPS or IDS are all worthwhile, it is simple logic to also lock the front door. It is far more effective to repair a half dozen actual risks than it is to leave them in place and try to build higher and higher walls around them. Network and website vulnerability scanning is the most efficient security investment of all. Now, let us learn some concepts related to web security. Number 1, SSL. SSL stands for Secure Sockets Layer. It provides a secure connection between internet browsers and websites, allowing you to transmit private data online. Sites secured with SSL display a padlock in the browser's URL and possibly a green address bar if secured by an EV certificate. Now, what is SSL used for? The SSL protocol is used by millions of e-business providers to protect their customers, ensuring their online transactions remain confidential. A web page should use encryption expected to submit confidential data, including credit card details, passwords or any personal information. All web browsers have the ability to interact with secured sites so long as the site certificate is from a recognized certificate authority such as Comodo. SSL allows sensitive information such as credit card numbers, social security numbers and login credentials to be transmitted securely. Normally, Data sent between browsers and web servers is sent in plain text, leaving you vulnerable to eavesdropping. If an attacker is able to intercept all data being sent between a browser and a web server, they can see and use that information. More specifically, SSL is a security protocol. Protocols describe how algorithms should be used. In this case, the SSL protocol determines variables of the encryption for both the link and the data being transmitted. SSL protects confidential information through the use of cryptography. Sensitive data is encrypted across public networks to achieve a level of confidentiality. There are two types of data encryption: symmetric cryptography and asymmetric cryptography. Symmetric cryptography uses the same key for encryption and decryption. An example of symmetric cryptography is a decoder ring. Alice has a ring and Bob has the same ring. Alice can encode messages to Bob using her ring as the cipher. Bob can then decode the sent message using his ring. In cryptography, the decoder ring is considered a pre-shared key. The key is agreed upon by both sides and can remain static. Both sides must know each other already and have agreed upon what key to use for the encryption and decryption of messages. Remember that the same key is used for encoding as well as decoding messages, thus the term symmetric cryptography. Asymmetric algorithms use one key for encryption of data and then a separate key for decryption. Asymmetric algorithms are more favorable than symmetric algorithms because even if the encryption key is learned in one direction, the third party still needs to know the other key in order to decrypt the message in the other direction. With asymmetric encryption, both sides can spontaneously spawn a transaction without ever having met. This is achieved by the use of a public and private key pair. The public key of the entity is public knowledge and is used for encryption, whereas the private key of the entity remains secret and is used for decryption. Now, why do we need SSL on websites? The internet has spawned new global business opportunities for enterprises conducting online commerce. However, that growth has also attracted fraudsters and cyber criminals who are ready to exploit any opportunity to steal consumer bank account numbers and card details. Unless the connection between a client and a web server is encrypted, any moderately skilled hacker can easily intercept and read the traffic. Now, how can I tell when a site uses SSL? When a digital certificate is installed on a web page, users will see a padlock icon in the browser address bar. When an extended validation certificate is installed on a website, the address bar will turn green during secure sessions. Users on sites with SSL certificates will also see https:// in the address bar. Now, who is behind SSLs? SSL certificates are issued by a certificate authority. A certificate authority will issue a certificate after it has confirmed the identity of the company applying for the certificate and that the applicant owns the domain named in the certificate. Certificates issued to a website are chained to what is known as a trusted root certificate, which is owned by the CA. These root certificates are embedded in what is known as the certificate store in popular internet browsers such as Chrome, Firefox and Internet Explorer. If the browser encounters a certificate which is not chained to a root in its store, then it will warn the end user that the connection is not trusted and that the user should not submit any confidential information. Next important concept is HTTP, also called Hypertext Transfer Protocol. HTTP is a set of standards that allow users of the World Wide Web to exchange information found on web pages. When accessing any web page, entering http:// in front of the address tells the browser to communicate over HTTP. Today's browsers no longer require HTTP in front of the URL, since it is the default method of communication. However, it is kept in browsers because of the need to separate protocols such as FTP. Some of the major facts of HTTP are: number 1, the term HTTP was coined by Ted Nelson. Number 2, the standard port for HTTP connections is port number 80. Number 3, HTTP 0.9 was the first version of the HTTP and was introduced in 1991. Number 4, HTTP 1.0 is specified in RFC 1945 and was introduced in 1996. Number 5, HTTP 1.1 is specified in RFC 2616 and was officially released in January 1997. Now, how does HTTP works? In the beginning, network administrators had to figure out how to share the information they put out on the internet. They agreed on a procedure for exchanging information and called it Hypertext Transfer Protocol. Once everyone knew how to exchange information, intercepting on the internet was not difficult. So, knowledgeable administrators agreed upon a procedure to protect the information they exchanged. The protection relies on SSL certificate to encrypt the online data. Encryption means that the sender and recipient agree upon a code and translate their documents into random looking character strings. The procedure for encrypting information and then exchanging it is called Hypertext Transfer Protocol secure. With HTTPS, if anyone is between the sender and the recipient could open the message, they still could not understand it. Only the sender and the recipient who know the code can decipher the message. Humans could encode their own documents, but computers do it faster and more efficiently. To do this, the computer at each end uses a document called an SSL certificate containing character strings that are the keys to the secret codes. SSL certificates contain the computer owner's public key. The owner shares the public key with anyone who needs it. Other users need the public key to encrypt messages to the owner. The owner sends those users the SSL certificate which contains the public key. The owner does not share the private key with anyone. The security during the transfer is called the Secure Sockets Layer SSL and Transport Layer Security TLS. We will learn more about TLS later on. The procedure for exchanging public keys using SSL certificate to enable HTTPS, SSL and TLS is called a public key infrastructure. Next is secure electronic transaction. Secure electronic transaction is an open encryption and security specification designed to protect credit card transaction on the internet. The current version SET V1 emerged from a call for security standards by MasterCard and Visa in February 1996. A wide range of companies were involved in developing the initial specification, including IBM, Microsoft, Netscape, RSA, Teresa and VeriSign. Beginning in 1996, there have been numerous tests of the concept, and by 1998, the first wave of SET compliant products was available. There are various features of SET. Let us discuss them one by one. Number 1, SET provides confidentiality of payment and ordering information. It is necessary to assure cardholders that information is safe and accessible only to the intended recipient. Confidentiality also reduces the risk of fraud by either party to the transaction or by malicious third parties. SET uses encryption to provide confidentiality. Number 2, it ensures the integrity of all transmitted data. That is, ensure that no changes in content occur during transmission of set messages. Digital signatures are used to provide integrity. Number 3, it provides authentication that a card holder is a legitimate user of a credit card account. A mechanism that links a card holder to a specific account number reduces the incidence of fraud and the overall cost of payment processing. Digital signatures and certificates are used to verify that the card holder is a legitimate user of a valid account. Number 4, it provides authentication that a merchant can accept credit card transactions through its relationship with a financial institution. This is the complement to the preceding requirement. Card holders need to be able to identify merchants with whom they can conduct secure transactions. Again, digital signatures and certificates are used. Number 5, it ensures the use of the best security practices and system design techniques to protect all legitimate parties in an electronic commerce transaction. SET is a well tested specification based on highly secure cryptographic algorithms and protocols. Number 6, SET creates a protocol that neither depends on transport security mechanisms nor prevents their use. SET can securely operate over a raw TCP IP stack. However, SET does not interfere with the use of other security mechanisms such as IPsec and SSL or TLS. Number 7, it facilitates and encourages interoperability among software and network providers. The SET protocols and formats are independent of hardware platform, operating system and web software. Now, let us compare both SSL and SET based on their advantages and disadvantages. Advantages of SSL. Number 1, transparency. Since SSL provides security at the session layer, its presence is completely invisible either to the merchant's web shop software or to the customer. This is especially important for merchants because there is no cost for integrating SSL with their existing systems other than the cost of installing the certificate. Number 2, ease of use for customers. SSL is already built into commonly used web browsers and there is no need to install any additional software. Number 3, low complexity. The system is not complex, resulting in minimal impact on transaction speed. Now, some disadvantages of SSL. SSL has some serious problems when it comes to meet the security challenges of today's financial sectors. Number 1, the merchant cannot reliably identify the card holder. SSL does provide the possibility of client authentication with the use of client certificates. Such certificates are not obligatory and are rarely used. Furthermore, even if the client possesses a certificate, it is not necessarily linked with his credit card. Number 2, SSL only protects the communication link between the customer and the merchant. The merchant is allowed to see the payment information. SSL can neither guarantee that the merchant will not misuse this information nor can it protect it against intrusions whilst it is stored at the merchant's server. Number 3, without a third party server, SSL cannot provide assurance of non-repudiation. Number 4, SSL indiscriminately encrypts all communication data using the same key strength, which is unnecessary because not all data need the same level of protection. For example, a credit card number needs stronger encryption than an order item list. Using the same key strength for both creates unnecessary computational overhead. Now, coming on to the advantages of SET protocol. Number 1, in the standard variant of the protocol, SET prevents merchants from seeing the customer payment information, since this information is encrypted using the payment gateway's public key. Number 2, ensures merchant privacy by preventing the payment gateway from seeing the order information. Then comes disadvantages of SET. Number 1, the customer must install additional software which can handle SET transactions. Number 2, the customer must have a valid digital certificate. Number 3, implementing SET is more costly than SSL for merchants as well. Number 4, adapting systems to work with SET is more complicated than adapting them to work with SSL. Number 5, business banks must hire companies to manage their payment gateways or install payment gateways by themselves. Number 6, despite being designed with security in mind, SET also has some security issues. In a variant of the SET protocol, the merchant is allowed to see the customer payment information just as with SSL. And then number 7, SET employs complex cryptographic mechanisms that may have an impact on the transaction speed. With this, we complete our today's lecture. Concluding today's lecture, we learned what is web security, how it can be implemented into our systems. We also learned various known and unknown vulnerabilities and defense strategies to counter these vulnerabilities. Besides this, we learned about various security related concepts such as SSL, SET, HTTP and HTTPS. Hope you have understood today's lecture. In the next lecture, we will learn about TLS, Kerberos and other protocols and billing systems. Till then, goodbye, have a nice day.